Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concept of derivatives. So as per the problem, the distance s in meters fallen by a skydiver t seconds after jumping and before the parachute opens is s equals 160 times 1 over 4t minus 1 plus e to the power negative t over 4. So let's start with part A. We have to find the velocity v at time t. So we can use the given distance function, and the velocity function will be the derivative of this distance function. So we can write v equals the prime of s, which is equal to, now in the given function 160 is the coefficient of the term, so it will stay as it is. Now we can find the derivative of the terms in the parentheses. So in the first term, 1 over 4 is the coefficient of the term, so it will stay as it is. And the derivative of t is 1. Now the derivative of the next term, 1 is 0 because it is a constant. And in the next term, this e term is the exponential term. So the derivative of this term will be the e term as it is given times the derivative of its exponent. Now the exponent here is negative t over 4, which can also be written as negative 1 over 4t. So in this exponent, the negative 1 over 4 is the coefficient of the term. So that will stay as it is. And the derivative of t is equal to 1. Now we can simplify this expression. So 160 will stay as it is. Now in the parentheses, in the first term, 1 over 4 times 1 is 1 over 4. The 0 goes away. And in the next part, negative 1 over 4 times 1 is negative 1 over 4 times e to the power negative t over 4. Now we can simplify this expression by factoring out 1 over 4 from both terms in the parentheses. So in the parentheses we get 1 minus e to the power negative t over 4. Now we can multiply 160 by 1 over 4 and we get 40. So this is the velocity of the skydiver at time t. So we are done with part A. Now we can analyze part B. So show that the acceleration is given by A equals 10 minus 1 over 4 v. So for part B, we have to calculate the acceleration, and we know the acceleration is equal to the derivative of the velocity function. So we'll find the derivative of the velocity function we found in part A. So A, which is the acceleration, is equal to v prime. Now in the velocity function, 40 is the coefficient of the term, so it will stay as it is. And in the parentheses, the derivative of 1 is 0 minus, and for the exponential e term, The derivative will be the e term as it is given times the derivative of the exponent. Now the exponent is negative t over 4, which is equivalent to negative 1 over 4t. So negative 1 over 4 is the coefficient, so it will stay as it is. And the derivative of t is 1. Now we can simplify this expression. Now in the parentheses, the 0 goes away, and negative 1 over 4 times 1 is negative 1 over 4, and then negative 1 over 4 times the negative e term will make the whole term positive. Now we can multiply 40 by 1 over 4, which is equal to 10. So this is the expression we got for acceleration. Now we have to check if we get the same expression for the right side, 10 minus 1 over 4v. We can use a different color. So 10 minus 1 over 4v can be written as 10 minus 1 over 4, and the v expression we got is 40 times now we can simplify this expression to see if we get 10 times e to the power negative t over 4 that we got for acceleration. So the first step is to multiply 1 over 4 by 40, which is equal to 10. We can continue here. So we get 10 minus, then 1 over 4 times 40 is 10. Now we can distribute the 10 outside the parentheses into the parentheses. So we'll multiply each term in the parentheses by negative 10. So negative 10 times 1 is negative 10, and negative 10 times negative e to the power negative t over 4 will be plus 10 e to the power negative t over 4. Now the 10s will get cancelled out, and we are left with just so that means the acceleration is equal to 10 minus 1 over 4 v, because we got the same expression on both sides. Now we can analyze part C. So we can continue here at the top. So in part C, we have to determine Vt, which is equal to limit t approaches infinity for function v. And this is the terminal velocity, the constant velocity attained when the air resistance balances the force of gravity. So we have to calculate Vt, and for that we'll have to apply the limit t approaches infinity to the v function, and the v function we got is 40, and then parentheses 1 minus e to the power negative e over 4. Now in the next step, before we apply the limit, we should move the e term to the denominator to make its exponent positive. So we get limit t approaches infinity, and then 40, 1 minus 1 over e to the power t over 4. Now we can apply the limit. So we get 40, and then 1 minus 1 over e to the power infinity over 4, because we have to sub in t as infinity. Now e to the power infinity over 4 will be infinity, because infinity over 4 is infinity, and e to the power infinity is infinity, and we know that 1 over infinity is equal to 0. So we'll get 40 minus 0, which is equal to 40, and the unit will be meters per second. So that means we can conclude that Vt is equal to 40 meters per second. So this should be the final answer for part C. Now we can analyze part D. So at what time is the velocity 95% of the terminal velocity? Now the terminal velocity we got is 40 meters per second. So the next step is to find what velocity is 95% of 40. So for that we'll do V equals 0.95 times 40. So now we can do this calculation, which is equal to 38 meters per second. So now we have to sub in this v value in the velocity function we got in part A and solve for time. So 38 equals 40 and then 1 minus. Now we have to solve for time, so we can move the e term to the denominator and make the exponent positive. Now we can divide both sides by 40. So the 40s on the right side will get cancelled out, and 38 divided by 40 is equal to 0.95. Now we can subtract 1 from both sides. So the ones on the right side will get cancelled out. So we'll get negative 0.05 equals negative 1 over e to the power t over 4. Now we can cross multiply the denominator. So we'll get negative 0.05 e to the power t over 4 equals negative 1. And now we can divide both sides by negative 0.05. So negative 0.05 on the left side will get cancelled out. So negative 1 divided by negative 0.05 is equal to 20. So in the next step, we can continue here on this left side. So e to the power t over 4 equals 20. Now we have to solve for t, so we'll have to move it down. So we'll apply ln to both sides. Equals ln 20. And now as per the power law of log, we can move the exponent t over 4 to the front of the term. So t over 4 ln e equals ln 20. Now we know that ln e is equal to 1. So we get t over 4 equals ln 20. And we can cross multiply the 4. So we get t equals 4 ln 20, which is equal to, so 4 times ln 20 is equal to almost 12, and the unit is seconds. So that means at 12 seconds, the velocity will be 95% of the terminal velocity. Now in part D, we also have to find how far has the skydiver fallen at that time. So that means now we have to sub in t as 12 in the given distance function and solve for s. So we can do the calculation here at the bottom. I can use a different color here. So the given function is s equals 160 and then parentheses 1 over 4 times t, and t is 12, and then minus 1, and then plus e with the exponent negative 12 over 4. So now we have to evaluate this expression. So s equals 160. Now in the parentheses, 1 over 4 times 12 is equal to 3 minus 1 plus e to the power. So negative 12 divided by 4 is equal to negative 3. Now we can simplify it further. So s equals 160, and in the parentheses, so 3 minus 1 is 2, and 2 plus e to the power negative 3 is equal to 2.04978. And now we can do the multiplication. So times 160, and I got almost 328. And the unit is meters. So that's how far the skydiver has fallen in those 12 seconds. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.